Welcome everyone back to Fun with WebGL 2.0, and this is going to be part 2 of our third lesson. We're talking about shaders. The first part was a lot of theory. Now it's time to start doing some code. So let's begin. So we're going to start off by opening up our gl.js file. And at the very top, you'll see that I've started to add global constants. These are just going to be the standard attributes that we'll be looking for all our shaders. These are common that we're going to need most often. We're going to need position, we're going to need the normals, and the UV. And then for each name of our attributes, we are having its position, because we're going to force those position numbers or those location numbers for each attribute. So no matter which shader we're in, those variables will always have that location number. Next up is we're going to add mesh cache as a private property in our GL context. This is really just to hold all the mesh data that we generate in our new function that we're going to create in a minute. The idea really is to save a list of all our buffers and VAOs. So down the line, if you want, let's say, clear out a scene, clean up after all the code and, start from scratch, we can actually just loop through our mesh cache and delete and unload all our buffers. So that's the whole point of this variable. Now comes one of our new big functions that we're going to add to the context. This is going to be called CreateMeshVio. This is going to create a struct that will contain our VAO ID and all our buffers and a bit of extra bit of information. This mesh VAO function is going to use our constants to grab all the main attributes that that we need. This is basically all the normal stuff that we need: the index, the vertex array, the normal array, and the UV array. Down the line, we might actually create other functions to create meshes, but this is going to be our standard for now, because this is really the main things that we need. So the first thing we do is create our vertex array object, our VAO. Then we bind it just like anything else. But the special trick about the VAO being bound is that once it's bound, certain things automatically gets applied to it. Instead of the global state, it's going to be applied to our VAO that we just bound. The main things that are going to be automatically bound to VAO is when we do enable vertex array and when we do vertex attribute pointer. Those functions are going to automatically be applied to the VAO. Now with our VAO ready to go, let's start with our first array. So we're going to check to see if array vertices exists and it's defined. So this function is going to create the buffer for us. It's going to start calculating our vertex count automatically for us. And then now we're going to start doing what we did before. We're going to bind the buffer. We're going to use buffer data to copy all our data into it. So now the GPU has all the data stored on it. Next, we're going to enable the attribute array. It's the number in which the attribute of our shader is going to use. So again, we're going to use our constants because we want to keep this standardized so it's easy to manage down the line. Now that the number or the position in the array is enabled, now we set the pointer to our buffer. And we've done this before. Now we're just doing it all over again, but with the VAO bound globally. So this would automatically set up our VAO position 0 of attributes to our vertex array. Now we kind of repeat the exact same code for our normals, and then we copy the same code for our UVs. The only difference is in the vertex attrib pointer function, we change it from 3 to 2 because our UVs are 2 floats instead of 3 floats. It's just an X and Y position data. And then we do our array index. And our array index is a little bit different because this one doesn't use floats, it uses ints. So you'll see that it just creates a uint16 array, which is an int array that's WebGL friendly, just kind of like how float32 array is WebGL friendly. And this one doesn't bound to our array buffer. This bounds to element array buffer. This is the main index buffer that kind of ties the other buffers together. So if we're asking for index 1, we'll get the index 1 for UV, normal, and vertex all at the same time in our shader. So this way everything's kind of grouped together per vertex. Then we should finish up the function just by unbinding our buffers and our vertex array. And it's very important to unbind our VAO because if you leave it bound open and you start doing other things, it would automatically be applied to that VAO. So once you're done using your VAO or buffers, you should really just clear them out, just so you don't have like some kind of weird glitches down the line that you don't realize. And then the last thing we do is we save the struct we just created to our mesh cache, and then we just return it to whatever function has called this function. Next, we're going to create a new JavaScript file called model.js, and within it, we're going to create a new class called model. For now, this class is not going to do much for us, but the idea is that we want to keep our mesh and our model data as two separate type of entities. Mesh data should be something that's shared across models. Like our models are really going to manage our transform information that our mesh data is going to have applied to. A quick example is a tree model, tree mesh. We're going to have one tree mesh data, but we might have like 1,000 models. So we have one bit of data that's stored on the GPU, but then we're going to have maybe 1,000 types of transforms. And the transforms can be anything between translate, scale, and rotate. So this way, we have one bit of data that we loop through, but then we transform and create on our screen at different locations, at different sizes, and even different rotations based on maybe a slope of the terrain or things like that. So that's the reason why we're splitting model and mesh as to two separate pieces. It's really better to manage data that way. If originally, when I created this the second time around, I actually had mesh exist in model. So once I had like a cube, I then had duplicate mesh data of the cube and repeat copies of buffers. And that's just really bad memory management. So this time around, by the third attempt, I actually split it apart because it makes more sense this way to handle it. So that's why we're doing it. So we're done with the model class for now for this lesson. Now let's open up our shaders.js file. Now we're going to start modifying a few things. We have our DOM shader program, and I'm going to do a quick modification to it, and we're going to put we're going to change the if statement for after the vertex shader has been compiled. If for some reason our fragment shader does not compile correctly, we want to delete the shader, our vertex shader, because we need to clean up. What's the point of leaving that shader available if for some reason our fragment shader crashed? So I changed that little bit of code. So we're doing some logical cleanup. So that's that. So that's a quick change for that function. And I made a copy of this function and created a new one called CreateProgram from text. The only difference is we don't get any DOM information, the text code in this function. This one we actually pass the actual text because later on we're going to create a shader base class, and our shader base class is going to determine how we get the shader code. It can get it from the DOM, or it can be hard coded, or it can come from an AJAX call from the server. So I want it to be flexible to the point where it just handles the compiling of shaders and linking of the program. So our create program from text is going to do that for now. Now we're going to move up to our create program function. This one we're going to do some small quick modifications, and it's quite small. All we're going to do is use something called bind attrib location, and this is where we're going to start binding the attributes that we want. There's going to be the vertice, the normal, and the UV array. So here's the 3 lines of code. That's all we're doing. We're just forcing those 3 variables to be the positions or the locations that we predefined. So if you don't like the variables that I created, you can then just set it globally in our constants, and the rest of the framework would then have it automatically applied. That's the magic of constants. Now the only thing to note is that I'm doing this before we link the program, because to bind the attribute locations, we kind of have to do it before the program is linked. So that's the reason why it's being done in this place. So that's all we have to really do for our create program. Next thing we're going to do is scroll to the bottom and create a new stack function called getStandardAttrib locations. All we're going to do in this simple function is create a struct that gets whatever current location our attributes are. Even though we are statically putting the location before the application is linked. If you don't have a shader that has the attribute, it's not going to have that number. So this tells us if the shader actually even has an attribute, a normal, or a UV attribute. So if position, normal, or UV equals -1, then we know that that shader does not have that attribute. So we can kind of use that to kind of tailor our shader functions down the line. Now we're going to bounce up to the top of the page and add our base shader class. We're just going to call it shader for now. It's going to be kind of simple. It handles a lot of the things we need to kind of just start up with. So we're going to just pass in our GL context, and then we're going to pass in the text source for both of our shaders, the vertex and the fragment. So I'll just step through it really quickly. It creates our program from text, the new function that we created. If the program was created, it's not null. We save our GL context so we can use it for a lot of our work. Then we use the program. So this way we can then start using our get standard attribute location. So we got our standard location attribute struct, and we save that into our shader class. And we have a uniform locations, and we're just creating an empty struct. Down the line, we're going to have a standard uniform locations, because there's going to be some uniforms that it's being very common that we're going to need. It's going to be called the model view, I forget what it's called, not perception, this perspective model view, and then the transform, the camera one. So we're going to have at least 3 uniforms that we're always going to be pushing to a shader just to get it rendered things out in 3D. So for now, we're going to leave it empty until we get to uniforms down the line. Then we're going to have some simple functions. We got activate and deactivate. That just turns on and off the shader at the global state. And this dispose, it kind of just deletes and cleans up our code a little bit. This dispose function needs to be worked up a little bit more, but for now we've got something in there that if we need to use it, we can actually clean and delete our data, our program. Next up, we have a function called Prerender. It's kind of like an abstract method that we can extend down the line with our subshaders. I've learned that there's certain points that we need to do some things before we start rendering. So when we're switching from one shader to another, we need to kind of set certain things. One thing that I know for sure, that the reason why I created this function was for textures. We need to rebind the textures when a shader has been activated. It's something we can't really use VAO for. So it's one of those small things we kind of have to handle before we render. And after that, we have render model. It kind of just handles all the rendering aspect of everything. So now we have everything done in kind of one fixed code. And here you can see we're binding our vertex array, or VAO, and then based on index count, we're going to change the drawing. So if we have an index set up, we're going to use draw elements, which just draws based on our index array. If we don't have an index, we're going to just use a function called draw arrays that we've been doing, which is just draws based on our vertex array. And when we're all done, we just unbind our vertex array, or VAO. Like I said, if you do not unbind things, it can cause problems. Like in the event that this shader has a texture and we don't unbind our VAO, the next shader that comes around, and if it doesn't bind the vertex array correctly, now you're stuck using a lot of the code from the previous run shader. So that can cause issues. So like I said, you bind your VAO and then you unbind it as soon as you're done, so you don't cause problems. That's hard to debug down the line. Now we're done handling with our shaders. I guess that's enough bouncing back and forth between the file and modifying a bunch of things. Now we're going to start doing the meat and potatoes of today's lesson. Now we're going to return back to our view.html page, and we're going to start doing a few things. One of the things we're going to do is add our new model.js file. And then we're going to create 2 new global variables to handle a couple of things we're doing. One of them is going to be the G shader, our global shader, and G model, which is our global model. So this way we can reference them later on in our unrender function. Now we're going to start bouncing to the end of our script tag, and we're going to extend our shader class. We're going to make a new shader called text shader. And as you can see, we have a constructor, and all we're going to do is pass in the GL, the context. So First thing we do is use our DOM shader source functions to get the source files from for our shaders, and then we use super, which calls the base class, the class that our shader is extending from. So we pass in our context and the source for the shaders to compile and then link the application. So this will kind of really starts up our shader, and it kind of gives us all the common stuff that we need. In our base shader, we have uniform location struct created, and it's empty. But our shader that we're creating, that we're using with test shader, it has some uniforms that we need. So now we're going to start customizing the base shader. So we just get the location of our point size and angle, just like from our previous lesson. And in our test shader, we're going to create a new function, and we're just going to call it set, because I really just don't have a name for it. So all it is, we're going to set our size and angle of the things we want to update in our shader, just kind of like our previous lesson, where we change the size of the vertice and then the angle in which it kind of rotates around the center. Now we're going to do a little bit more bouncing around. Now we're going to go back to our load event, and we're going to start replacing a lot of our shader code. So here's what it looks like from our last lesson. So now we're going to do we're going to pretty much just wipe everything out and replace it with a single line. We're going to assign GShader to our new test shader, and we pass out a GL function. So all that code now has been reduced to a single function call. That makes things so much easier. Now next up, we're going to create our buffers differently. Now instead of creating our buffers and kind of doing everything manually a little bit, we're going to use our new CreateMeshVio, which kind of handles a lot of the buffer making and linking and all that good stuff in one go. So all we do is give it a name of the mesh that we want to save in our cache, and then pass in our vertice array. The only difference we're going to do is we're going to change the default draw mode, because normally down the line when we're actually drawing real meshes, it's going to be, the draw mode is going to be triangles. But since we're not drawing triangles yet, we're going to override the draw mode to points. And then now with that, how we have our mesh VAO, we're going to create a new model and just push that into that. Now to finish up our load event, we're going to move to the next section, which is set up for drawing, and we're pretty much going to wipe everything out except our loop. So setup for drawing now is simpler, and now it's just one line of code. So if you start looking at how our load event looks like, it's been slimmed down a lot. Our shader code is done in one line of code. We get our model and our meshes within 3 lines of code, and then we just set up our loop within 1 line of code. So initialization looks neater. It looks easier to manage, and everything else is kind of exists its own functions and classes to facilitate our framework to get this really started really quickly. Next up, we're going to modify our unrender function. So here is what it looks like, and now we're going to pretty much comment most of it out and just start adding our clear, and then we're going to use our shader to actually handle all the code. So our shader, we got our shader, and it's everything. A lot of things are chainable, so I kind of made everything into technically one big long line of code, but it's in its own separate lines just to make it easier to view. But it's really just a single line of code. So we have our GShader, we tell it to activate, and then we use our set function. And I do some weird things here that you might not notice it, and maybe it makes it hard to read. But that's why we commented out the previous code in onRender, so you can kind of compare. Within a single line of code, I'm actually assigning a variable and getting its results. So we can kind of slim everything down and optimize it to as least amount of code as possible. And we do the exact same thing for GAngle. We kind of assign the variable a new value, and then we get it at the exact same time, and then we pass it to our set function. Once our attribute uniforms are completely set up, ready to go, then we call our render model function and pass in the GModel function, and it should render what we had before. So at this point, we changed so much of how everything works today, and we slimmed everything down, and now we're back to kind of where we were at the end of the last lesson. It's just a pulsating pixel that kind of just rotates around the circle. So this would be a good point to end it, but let's not end it yet. Let's tweak some things. Let's modify our code. So we do a little bit more than we did in the last lesson. So the thing we're going to do is we're going to go back to our CreateMeshVio in our load event, and we're going to add 4 more points to our vertex array. And each point goes to one of the 4 corners around our center point. So just with that small modification, save and go check out the browser, and now you'll see that you have 5 points rotating around the center, pulsating. So let's not stop there. All right, so let's go back to our HTML page and scroll down till we get to our shader code that exists in script tags. So here is what it looks like so far. So we're going to do some tweaking. One of the first things we're going to do is in the vertex shader, we're going to set the precision of our U-point size, because the precision that exists in our fragment shader is, by default, it's medium P. So we need to set it at our vertex shader as medium P, or you're going to get an error saying they're not compatible because they're different size floats. Then we start tweaking our fragment shader. Then we put in our U-point size, so this way we have access to the uniform in this shader as well. And then in our main function, we're going to change how our final color is finally rendered. So we're going to create a float called C, just color, and we're going to do this little math equation. Now, if you remember from the previous lesson, point size fluctuates between 20 and 40. So the idea is that if for some reason, or not for some reason, when U-point is at 40 and we subtract from 40, it'll create 0, and if we divide by 20, it would create a value of 0. So if we use the value of 0 as for colors, so if we have 3 zeros, that creates the color black. So if for some instant that U-point reaches 20, so 40 minus 20 makes a value of 20, and 20 divided by 20 is 1. So now we have a color value of 1. If we have 3 colors, 3 RGB as 1, that creates the color white. So now we're actually going to alternate back and forth between the color black and white in our fragment shader. So it's a little fun mathematical thing I did just for fun for this lesson, just so we can do a little bit more. So now if you go back and refresh in our browser, now you'll not only see 5 vertices circling around and pulsating, now you see it looks like it's fading in and out. So the smaller it gets, it fades away, and the bigger it gets, it fades to its maximum color of black. It's just smoke and mirrors. So it's not really transparent. It's just because the background is white that we're going into white. But it creates that nice effect. So I just added this at the end just for a little fun, so we kind of learn a little bit more. We're playing with numbers, and we're really experimenting with some things that we can do. So that's pretty much it. This is the end of the lesson. If you stayed this long for both parts, God bless, and thanks for staying around and listening to me babble on long-winded, I guess, for a lot of things. So so yeah, hopefully you got a lot to do. We got the framework really extended. Our initialization code has got slimmed down. It looks less scary nowadays. Hopefully you learned how everything works now, how to get VAOs working, how buffers are kind of put together, and how we're kind of start manipulating our vertices with mathematics. Hope you're having fun. So I'll see you guys in the next lesson, and if you want to help me out, subscribe and like, it'll help, make me a couple of pennies here and there. So thanks a lot, and I'll see you guys in the next lesson.